In this lesson, we're going to extend our study of roots. Remember in the previous lesson, we looked at square roots. In this lesson, we're going to look at cube roots and other roots such as fourth root, fifth root, and so on. Now, make sure before you embark on this lesson that you go back and make sure you understand the information that we learned with square roots. So remember in the previous lesson, just a quick review because this idea is going to be needed here. We really looked at the square root of, let's say, 81. So remember we said the square root of 81 was equal to 9. And the reason we thought that was because when we said this, we said 9 times 9 is equal to 81. The radicand, remember the radicand here is 81. So remember the square root is a reverse of squaring. And so if you have 9 squared equals 81, then if I take the square root of 81, I'm going to get the base here. I'm going to get 9 back. Okay? And so we're going to use this idea when we talk about cube roots. Okay, so for example, we know this. We know, all right, so let me write the word for example, since 2 to the third power is equal to 8, okay, this idea here, 9 squared equals 81, and so then when I take the square root of 81, I should get 9, right? So if 2 to the third power equals 8, we call 2, this right here, we call 2 the cube root of 8. So just like we did here. So when we said 9 squared equals 81, we call 9 the square root of 81. So the square root of 81 is 9. So if I have 2 cubed equals 8, then we say the cube root of 8 is equal to 2. Now, let's discuss how we write that radical symbol, that radical sign. So here's what we say in symbols. All right, so it's important you listen carefully to this. So we write the cube root like this. So we write the radical sign, the radical symbol, and the cube part will be a 3. Remember, cube means 3. You can see the number 3 here, 2 cubed. But the cube root, the 3 goes here. So it looks just like this. Now don't put it in front. See, many students, they'll do this. Well, that's not cube root. That looks like 3 times the square root. So don't do that because this looks like 3 times the square root. Okay? So if you want the cube root, then you got to put the 3 here. And that's called the index. So that's called the index. All right, so remember in the previous lesson we talked about square root. We never mentioned the word index. So we just knew that something like this meant square root. Well, now we're going to talk about the index here. So the index is this number right here. And you may say, well, there's no number there. Now be careful. Remember when there's usually not a number like coefficients, we think of it as being a 1. Or for an exponent, if I don't see a number, that exponent is understood to be a 1. Now that's not true here. The square root, this is square root. That index, if there's no index there, it's understood to be a 2. The index is 2. So that's why we say square root. Here the index is 3. So we say cube root. Okay? So we say cube root. All right, so be careful how you write it. Don't write it like this because that looks like 3 times. Make sure your 3 looks like an index. It's got to be in this little part right here. So if I'm writing a little bit bigger, like if that's the symbol, then put the 3 here. See how it looks? That's where you put it. Okay? That's where you put it. So that's the cube root symbol. So let's go back to this here. So when we say that 2 cubed equals 8, then 2 represents the cube root of 8. So that means this. The cube root of 8 is equal to 2. That's what that means. Okay? All right, so what about this one? So let's find each cube root. So find each cube root. All right, so number 1, the cube root of 64. So in your mind, you're thinking this, and do this without a calculator. Do this one without a calculator. So remember, cube root of 64 means this. What times itself 3 times is 64? So what number times itself 3 times is 64? All right, so I mean, try something. 3 times 3 times 3. And when I say don't use a calculator, what I mean at this point is this. Don't use your cube root button. Now, if you need to use your calculator to say, well, 4 times 4 times 4, then that's fine. Okay, that's okay. Oops, I keep getting an error here. Okay, 4 times 4 times 4, that's fine. Oh, and I got 64, right? So 4 times 4 times 4 is 64. And remember, this also means this. This means 4 cubed equals 64, right? So 4 cubed equals 64. Then, remember, this is cube. So the reverse of cube is cube rooting. So if I take the cube root of 64, that's going to equal 4. So this right here equals 4. Okay? All right, number 2, let's suppose we had the cube root. Remember, we're dealing with cube roots here. The cube root of 1 divided by 8. All right, well, just like we did before, I know I can write the cube root of 1 divided by 8 as the cube root of the numerator divided by the cube root of the denominator, right? And so I don't need a calculator for this one at all, because I know the cube root of 1, remember that means what times itself 3 times is 1. Well, the only thing that works is 1 times 1 times 1. So that's 1. In fact, the cube root of 1 is 1. The square root of 1 is 1. The fifth root of 1 is 1. Okay? So whatever your index is, if the radicand's 1, then this is going to be a 1. What's the cube root of 8? So what times itself 3 times is 8? 2. So there's your answer. All right, so the cube root of 1/8 is just 1/2. Okay? Now, I want to remind you about something. So this is a reminder. Do you remember in the previous lesson when we talked about square roots, we said this, I asked you, what is the square root of a -8? What did you say? So what times itself 2 times is -8? Well, remember, that was not possible, right? That was no real number. And we're talking about real numbers here. So we said that this was not a real number, okay? And so we saw that the square root of a negative number will never be a real number. Now, I did mention that very soon we're going to look at imaginary numbers, and that's where that idea that I, you may remember the symbol I, will come into play. Now let's look at number 3, though. Knowing this, let's look at number 3. What about the cube root of -8? Is that also not a real number? So I know that the square root of -8 is not a real number because there's no number times itself, no real number times itself that's negative, right? What about the cube root? Is there a real number times itself 3 times that's going to equal -8? Can you think of one? Okay, good. You said -2 times -2 times -2, right? So -2 times -2 times -2 is a -8. 2 times 2 is 4. 4 times 2 is 8. A negative times a negative is a positive. A positive times a negative is a negative. So the answer is -2. So it turns out that the square root of a negative number is not a real number, but the cube root of a negative number is a real number. Okay? All right, let's look at the next one. So let's look at number 4. Number 4, let's suppose we had the cube root of -125. All right, now first of all, I'm going to ask you, is this a real number or not a real number? I'm taking the cube root, right? So I know that I know that if I multiply some real number by itself 3 times, I can get a negative number, because a negative times a negative times a negative is a negative. Okay, so that is a real number. The question is, can I come up with 3 numbers multiplied by itself 3 times, a number multiplied by itself 3 times that's negative 125? That's the question. So you may say, what about 5? All right, well, 5, let's check it first. Use your calculator if you need to for that 5, but don't use the cube root button. Just 5 times 5 times 5 is 125. So, but it has to be negative, right? And so there's the answer. So the answer is negative 5. There's your answer. Okay, let's do number 5. Number 5, let's suppose we had this for number 5. Okay, number 5. We have the cube root of 27 divided by 1,000. The cube root of 27 divided by 1,000. Okay, so just like we did in this problem here, this one here, where we wrote it as the cube root of the numerator divided by the cube root of the denominator, do the same thing. So this is going to be the cube root of 27, right, divided by the cube root of 1,000. The numerator is easy. You can figure that one out. What number times itself 3 times is 27? Well, that's 3, because 3 times 3 is 9. 9 times 3 is 27, right? So 3 cubed does equal 27. So then the cube root of 27 rather, is going to be 3. For 1,000, can you guess as to what that is? Again, don't use your calculator. Don't use the cube root button on your calculator. So what about 10? So 10 cubed is 1,000, right? So that means that the cube root of 1,000 is what? 10. So that's 3 tenths, and there's your answer. All right, number 6. Number 6, let's suppose we had the cube root of a negative 27 divided by 8. Now, is that a real number? Yes or no? Yeah, that's a real number. I can take the cube root of a negative number. It's going to be a negative number. Now, I just got to figure out what the cube root of 27 is and the cube root of 8, right? And so I already know what the cube root of 27 is. I found in the previous one. That's 3. So I get negative 3 divided by. And the cube root of 8, remember the cube root of 8, so 2 times itself 3 times is 8. So if 2 cubed is 8, then that means that the cube root of 8 is 2. So the answer is negative 3 halves. Okay, number 7, we have the cube root of 0.216. 0.216. All right, now, again, nowhere in there does it say use a calculator. So don't use a calculator in this. So just do this. So you know it's a decimal, right? So this is something like, let's say, 0.5 times 0.5 times 0.5. See what happens. So I get 0.125. That's not what I wanted, right? I wanted 0.216. So maybe we need to go higher than 0.5. So remember what I'm trying to find is this. What number times itself 3 times is 0.216, correct? Okay, so let's try 0.6. 0.6 times 0.6 times 0.6, and I get, hey, there it is. So 0.6. So the cube root of 216, the cube root of 216 is 0.6. There's the answer. All right, number 8 rather. Number 8, what if I had this? What if I had the cube root of negative 343? The cube root of negative 343. Okay, so again, don't use a cube root button in your calculator. Just kind of understand what you're trying to find. You're trying to find a number multiplied by itself 3 times that's going to equal a negative 343, right? So try now 5 won't work because if you do 5, remember what that was? That's 125. 5 times 5 times 5. All right, let's try, let's say 8. 8 times 8 times 8 equals 512. I need 343, so let's try 7. 7 times 7 times 7. There it is. Okay, but is it 7 or negative 7? It's negative 7, right? So if negative 7 cubed is negative 343, then that means that the cube root of negative 343 is negative 7. Now, what about number 9? Let's suppose I wrote this back like this, but then I had this. Okay, watch. I put a negative out in front. What changes? All right. Now the way I would do this is this. I would cover this negative out here. Now remember, let me remind you about something, about how to say something. So if I had this like that, then I can read this way. I can read this right here. I could read it as the opposite of negative 6. And so what's the opposite of negative 6? Well, the opposite of negative 6 is a positive 6, right? And so the same thing here. I can read this as the opposite of the square root of negative 343. I'm sorry, the cube root. The cube root of negative 343, which I already found, so that's the opposite of negative 7. And what's the opposite of negative 7? Remember what this means is this. It means this, right? So the opposite of, and that's, we found already, negative 7, and so the answer is just 7. Okay? All right, now, in the next 2 problems we're going to use, actually the next 3 problems we're going to use a calculator with is going to say this, approximate. And we did this in when we talked about square roots as well, where we used the calculator to approximate. So approximate to the nearest 1,000. Okay, so what if I had something like number 1? What if I had the cube root of 10? You see, and we had that same discussion when we talked about square roots. So notice when I did number 1, I asked what's the cube root of 64, and so that was easy to deal with because we knew that there was a whole number multiplied by itself 3 times. 4 times 4 times 4, that was 64, right? Same thing here. There was a whole number multiplied by itself 3 times, that was 8. It was 2. The same thing for negative 8. Well, in this case, it would be an integer, negative 2. And then here was negative 5. So those were integers. But here, can you think of a whole number? See, this is positive now. The radicand is positive. So can you think of a whole number times itself 3 times, that's 10? No, because 2 times 2 times 2 is what? 8, and then 3 times 3 times 3 is 27. So you don't get 10. So then we have to approximate. All right, we have to approximate. Now, what I was using here, like the cube root of 27 was 3, because 3 times 3 times 3 is 27. And then the cube root of 1,000 is 10. 10 times 10 times 10 is 1,000. Remember when we dealt square roots, we called those perfect squares. So these would be called perfect cubes. Let me just mention something. So perfect cubes. Perfect cubes. So your smallest perfect cube is 1, just like with perfect squares. The next one is 8, and here's how we get them. So remember, 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. Okay? And notice when I do the reverse, if 1 cube is 1, then the cube root of 1 is 1. If 2 cube is 8, then the cube root of 8 is 2. If 3 cube is 27, the cube root of 27 is 3. If 4 cubed, and 4 cubed is what, 64? Then the cube root of 64 is 4. 5 cubed is 125, so the cube root of 125 is 5. And then we're going to stop there because it's going to get much larger. Okay? So those are perfect cubes. So all of these that we dealt with were perfect cubes. now negative, and remember the smallest perfect cube is 1, but I can say this, that for cubit of negative 8, cubit of negative 8 here, it was the opposite of a perfect cube. So if 8 is a perfect cube, then negative 8 would be the opposite of 8. Okay, so those were perfect cubes. See, 10 is not a perfect cube, right? Because there's no whole number times itself 3 times, that's 10. So I'm going to use a calculator. All right, so we know how to use square root in the calculator. Let's determine how to use cube root. Okay, so I don't have my glasses on, but right here, okay, so you see, right, and you got to find it in your calculator. So right above the x squared button, remember that was square root? Okay, so you see right here that looks like a roof, like that arrow. So you'll see something that looks like the x root right here. You can't see it very well, but it looks like this. So on the calculator, find something that looks like this. Now your calculator may be different, so you gotta know where your function is. It'll look something like this. So this means x root, okay, or the nth root. But my calculator has the letter x. All right, so here's what you can do in your calculator. So on the calculator, you're going to put the index first on mine. So I'm going to say, watch, I'm going to say 3, okay? Then I'm going to press the second function and then press this right here. So watch, second, and then this, and then notice this, even though it looks like 3 times, it's really the cube root here. So it's a cube root of, and then I type in 10 for my right hand, close the parentheses, and then press equal. Oops, I got an error, so let me see what I did. Oh, okay, so let's do this again. So 3 cube root, okay, and then 10, okay, so I get 2. Now remember, the thousandths place is three decimal places, right? So look, the 1's in the tenths place, the 5's in the hundredths place, the 4, this first 4 is in the thousandths place. So you got to look at the 10,000. So you look at the 4th place here. So since that's less than 5, then the 4 will stay 4. So the answer is 2.154. So approximately equal to 2.154. Okay? All right, number 2. Let's suppose we had the cube root of negative 20. So again, 20 is not a perfect square. All right, so I'm going to have to approximate this. So one thing I can do is just approximate. So in your calculator, you're going to say cube root. So you're going to type in 3 first, then press second, and then that button right here. Okay, then negative 20, and then enter, and so you get negative 2.714. So negative 2.714. All right, so the nearest thousand, remember the nearest thousand, that's the 3 decimal places. So since this is less than 5, then 4 stays 4. And then let's do one more. So number 3, we have negative cube root of 162.73, let's say. All right, so I know the answer is going to be negative, so I'm not going to put the negative in here. So I'm going to take the cube root, and then that's going to be 162.73, and then press equal, and you get 5. All right, now let me write this out. So I get 5.4595377, and so on. Okay. All right. So listen carefully. So you're gonna have to remember something from previous courses. So you want to round to the nearest thousand. So that's going to be here. I notice that this digit right here is 5 or bigger, so I've got to add 1 to this, right? So when I add 1 to the 9, this 9 becomes a 10. So that means this 5 here, I need to add 1 to that, so that becomes a 6. So this becomes 460. 5 plus 1 is 6. All right, now remember it says round the nearest thousand, so you still need that 0 there. So don't say negative 5.46, because you rounded to the nearest hundredth here. You got to round to the nearest thousand, so I need something in the thousands place, and that's at 0. So make sure you have 3 digits behind the decimal point. All right, so that was number 3. Okay, now, so that was cube roots, right? Okay, and so what we're going to look at now real quick is the idea of other roots. Actually, let me go ahead and do that in another lesson. So this was cube root lesson, and I'm going to go ahead and change this to just cube roots. So we're just going to take this part off, and this right here. So this is a lesson dealing with cube roots only. Okay. All right. So cube roots, and then the next lesson we're going to talk about fourth roots and fifth roots.